Good morning, all of you. So now let us come to here. Now today's class we are going to study first why the sun appears red at the sunrise and sunset, and as well as experiment to study the scattering of light. Now first we will discuss why the sun appears red at sunrise and during sunset. So let us discuss in detail what is the phenomena behind. So as we know that the phenomena behind during this one also, like why the sun is appears red and sunrise during sunrise and sunset also is the only phenomena called as what is that? Scattering of light. What is that? Light. So the only principle or phenomena behind this natural effect is also scattering of light only. So now how the scattering of light takes place and what is the phenomena exactly, we will discuss now. So if you'll observe very carefully, this picture will give you the clear idea regarding sun during the rising, during sunrise you can see, and during sunset and at the noon over our head. So if you see here, the sun and the surrounding sky, appears red at sunrise and sunset because of the because at that time most of the blue color present in the sunlight has been scattered out. You can observe here during sunrise and sunset, the most of the blue light scattered away. So only the mainly red light reaches us. That is why the sun and the surroundings appears to be red. Do you understand, guys? In the same way, evening also, during sunset also, most of the blue light is scattered away and only the red light, mainly the red light reaches to us. That is why during evening also, the sun and the surroundings of the sun appears to be what? It appears to be what? Respond me. It appears to be red in color. Do you understand?
Red in color.
If you observe here, mainly the red color in the understanding direct sunlight of the beam that reaches to our eyes. So that is the reason during sunrise and sunset only the red light reaches our eyes, so that we are able to see the red color surroundings of the sun also. So now during afternoon time only little of blue light is scattered. That is why the sun is appears to be which color? What is the sun color? What is the sun color? It is white in color during noon time. So now what is happening exactly and how it takes place, let us discuss very in detail. Now three things here you have to remember. So during sunrise, what is the sun color? Anybody? During sunrise, what is the sun color? Arya? During sunrise, the sun appears to be red. Sun and the surroundings of the sun appears to be red. Because what is the principle? Most of the blue light is scattered away. Why it is scattering? We will study now. Most of the blue light is scattered away, and which light is reaching mainly? Only which light is reaching our eyes mainly? Which light? Red color light reaching our eyes mainly. The same thing if it comes to the evening also. What is happening? Most of the blue light is scattered away, and which light is reaching mainly? Red light is reaching us. That is why the sun and the surroundings appears to be red in color. Now noon time means during afternoon 12 o'clock. Understand? So noon time, if we take little of blue light is scattered, and that is why the sun appears to be aura, guys. What is the color of the sun? What is the color of the sun, Bhumika? Yalni? Color of the sun is white in color. This is the person standing here. You can see I am the one who is standing here. Observer on earth. So morning I am looking here, evening I am looking here, and noon time I am looking here. So I am able to see the different colors of sun. Morning and evening I am able to see. During sunrise and sunset, the sun appears to be red, and noon time it appears to be white. So let us see why and what is the phenomena behind here. So you can see at the time of sunrise, what is that first one? At the time of sunrise and as well as at the time of sunset. At the time of sunset, when the sun is near the horizon. What is that? Sun is near the horizon. Do you understand, guys? What is the horizon point? I said, what is the horizon, Ra? Ocean. Is it yes or no?
Ocean.
That called as ocean is our, or sea is our horizon. So during sunrise and sunset, during sunrise and sunset, sun is near the horizon. Sun is near the horizon, and the sunlight has to travel larger distance or greater distance. What is that? The sunlight needs to travel what? Greater distance. Understand, guys? Greater distance through the atmosphere. Greater distance through the atmosphere. So as we know that once it will reaching to our eyes, it is traveling lot of distance. Understanding? Greater distance. So that is why each and every point, lot of amount of blue light is scattered away. What will happen, guys? Lot of, tell me, Ra. Lot of blue light is scattered away because during sunrise and sunset, the sun is at the horizon. Sun is near the horizon. So by the time, much larger distance or greater distance between the sun and the observer. Between the sun and the observer. So each and every point, most of the blue light is scattered away. Understanding? Little bit. So what is happening? Most of the blue light, when it is coming to the observer, the blue light is not sufficient blue light. Sufficient blue light is reached, so that it is not appears to be white in color. Only the red light reaches us first. That is why the sun is appears to be what? Sun is appears to be what? Red in color. Understand, guys? Because what is the phenomena? You know that red light, who is having maximum wavelength? Who is having more wavelength? Red color is having
red light
more wavelength, so that it will travel much faster or slower. Greater speed or smaller speed? Lesser. Red light. Red color light. Larger speed or smaller?
Larger speed. Larger speed.
Because of greater wavelength. Understanding? Because of greater wavelength. Understand, guys? So the red light will travel first and it will reach us to our eyes, observer first. That is why the sun and the surroundings is appears to be red in color. But because of large distance, each and every point, the blue light is started scattering. Scattering by whom? Scattering by the atmospheric particles. So that it is appears to be what? During sunrise, the sun is appears to be what? Red. Understand? And the surroundings also. So during this long journey, because of larger, greater distance, so it is a long journey. So most of the shorter wavelength light. What is the most of the shorter wavelength? What is the shorter wavelength light? Anybody? Shorter wavelength light. What is that? Blue light. Speak louder. Understanding? Shorter wavelength, blue light. Understanding? Blue color present in the scatter. Understand? Present in the light, sunlight is scattered out, and understanding away from our line of sight, so that the light reaching us directly from the during sunrise as well as during setting sun. Understanding? During sun setting. So both sunrise and sunset, both the situations. So greater distance. Understand, guys? Because of very long journey of light, most of the shorter wavelength light is scattered away by the atmosphere. Only which light will reach us? Which light will reach us? It is mainly the longer wavelength, red color light is reaches to us, reaches to the observer. So that is why, due to which the sun appears to be what? The sun appears to be red in color. Do you understand, guys? So that is the reason. Due to the same reason, the sky surrounding during the sun rising and sun setting the sun also appears to be red, because the surroundings also we can able to see the sun, like a projection of the red color is appears to be surroundings of the sun is during the sunrise and sunset also. It will also appears to be what? Appears to be what? Red in color. Do you understand?
The blue light scattered down, sir.
It will be scattered away, not down. It will be scattered away when it is traveling long distance, because of long journey, each and everywhere by the atmospheric particles, it will be scattered away. So finally, only red light will reach us during morning and evening time, during sunrise and sunset. That is why the sun appears to be red in color. Do you understand? Okay. So now, if you'll observe here, at the sunrise and sunset, the sun itself and as well as the surrounding sky appears red because of the Vaira. What is the phenomena? The scattering of light. What is that? Scattering of light. Sir, what is the reason behind during red color? You may have asked me. So, most of the blue light is scattering away. So, not sufficient blue light is reaching. Not a sufficient blue light. Blue light is reaching our eyes. So that is why the sun appears to be only red color. Why can't? Understanding? Not in white in color during sunrise and sunset. Understand, guys? Please respond me. That is what is happening. But during noon time, what is happening? You know that Earth is revolving around the sun. Anyhow, we are considering when we are in an observer, only we can see sun is rising. Is it yes, guys? Sun is rising on the east and sun will setting on the what? West. Is it yes, Ra? Respond me. Sunrise at the east and sunset at the west. That is what we will study. So sun is only moving. So now during noon time, what is happening? Let us discuss why the sun appears white when it is overhead in the sky. Overhead in the sky. What do you mean by overhead? Anybody? Respond here. Why are you silent? Jesse, Nitinath, what do you mean by overhead? I want to know that. Overhead means exactly on our head. Is it yes or no? Midday, like in the sense of noon time, afternoon time, why the sun appears to be red, we are going to study now. So observe very carefully. Why the sun appears white when it is overhead in the sky means when the sun is overhead. All of you remember, overhead means at what time, Ra? At noon time. At what time? At
noon time.
Then the light coming from the sun is to travel compared to this distance, compared to during morning and during evening, understanding the relatively shorter distance. What is that? It needs to travel relatively shorter distance, so that what is happening, guys? Shorter distance it is traveling, so that little of blue light is scattered, and you can see remaining blue light along with other colors of light, it is reaches to our eyes. So if all the colors are reaches to our eyes, the sky appears to be what? Now the sun appears to be what? If all the colors of light is reaching to our eyes,
White.
what color? White color. Because all the 7 colors will reach us. 7 color reaches to us. Then what is the color? It appears to be white color. Understand? So because here you can see it is traveling shorter distance. Noon time, the distance between the observer and the sun is less compared to the during sunrise and sunset. So during sunrise and sunset, the distance between the observer and the sun is much relatively larger distance or greater distance, but noon time it is shorter distance. Understand, guys? Yes or no? So during this shorter distance, during this shorter journey of sunlight, only little of blue light is scattered and remaining blue light, understanding? So remaining blue light is remains in it unaltered, so that it will reach us to our eyes. So that is why what? Most of the blue light remains with other colors. So that is why it appears to be what? White light is scattered. Understanding? White light, so that the sun appears to be which color? During noon time? White color. Understand, guys? So that is the reason the light coming from the overhead sun has almost all its component. So 7 colors light is present. So that is why you can see what is the color, right? 7 colors of light is reaching to us. What is that? It appears to be
White.
white color, because all the colors, very little blue light is scattered, and remaining light, understanding, remaining blue light is again in it only, so that all the colors are in very right proportion to form which color light? To form which color light? To form white light. Understanding? So that is the reason the sun in the sky observed, understanding, during overhead, he appears to be which color? White to us. Understand, guys? White to us. Now, here, sir, then morning and evening, what is happening? The blue color light is not enough sufficient to reform white light. That is why the red color, the red light is reaching us much faster. Because of why the red color light is reaching us? Anybody? Why the red color light is larger? Because of greater wavelength. What is that? Greater wavelength. Blue light is having shorter wavelength, means a larger frequency. So what is happening? At each and every stage, it will be scattered away. What will happen? Each and every stage, it will be scattered away. The reason it is going to scatter away at each and every stage. So that is the reason the not enough sufficient blue light is reaching our eyes. That is the reason during the sunset and sunrise, the sun and the surroundings appears to be red in color, because all the colors of light not in a right proportion during morning and evening, sunrise and sunset, but noontime, all the colors which is reaching to the observer, they are in a right proportion. That is why the sun appears to be white color. So what is the phenomena behind? Anybody? What is the principle behind here? Jesse, Elamati, can you answer? Tarani, what is the principle behind? Because here, what is that? Greater distance. Understand? Long journey of sunlight during sunrise and sunset. But here, what is that? Noon time. Shorter. Understand? It needs to travel very little journey, understanding, shorter distance. So that is why shorter journey during noon time and longer journey, understanding. So long journey during sunrise and sunset. So here, because of long journey, most of the blue light is scattered away. But here, because of shorter journey, understanding, so shorter distance, so little of blue light is scattered, and all the colors, remaining blue light along with all the colors is enough sufficient to form white light. That is why the sun appears to be white during overhead at noon time, but so during sunrise and sunset it appears to be red in color. Please, all of you, draw this diagram. If you draw this diagram, one MCQ 100 times one MCQ come from this concept for your board exam also. Remember that, and based upon that, you have to remember that. A very important concept this is. Please, all of you, note it down. Very important concept. Much larger distance. Here, shorter distance. Have you drawn this diagram? Are you understand, everybody? Any doubt, anybody? This is called as why the sun appears red at sunrise and sunset. Any doubt, anybody? Pranav, Tarani, Nitish, Jesse? No? Yeah. Good morning, Akshay, Arun Karthikayan. Jesse, call to Pranita. Tell them to wake up fastly. Arya, understand, Arya, this concept? Clear?
Yes, sir.
Okay. Everybody, I hope you all understand. Any doubt here? Bhumika? From this, definitely one question will come, but they may be twisted. We have to be very clear, which is means shorter wavelength, larger wavelength, next longer distance, shorter distance, long journey, short journey, like that they will ask you. So based upon that, you have to be very clear. So always one observer, exact picture you have to remember in brain, so that you will never do any mistake. Understand? So this is what it is, why the sun appears red at sunrise and sunset. Any doubt, guys? Anybody? Please respond me. Yes or no? So now, if there is no doubt, then we are going to the last concept of this chapter. That is what we should call as experiment. What is that? Experiment to study. Experiment to study the scattering of light. Scattering of light. Okay. Shall we start?
Yes, sir.
Yeah. So now,
Yes, sir.
as you know that in class 9 you people are studying, which light will show the path of the light, guys? Which particles, which substances will show the path of the light? Like solutions, suspensions, and colloids. Which one? Solutions, suspensions, and colloids. Which one will show the light?
Colloid.
Light.
Sir,
Ah.
colloidal solution.
Colloid, sir.
Understand? So colloids only will make the see the path of the light clearly. So solutions cannot make it because they are the true solutions. So solvent is completely dissolved. So suspensions only when the particles are floating it will scatter the light. Remaining time does not. Once they will settle down, it is not. But this one, colloidal substances, they always will scatter the beam of light because they have some understanding. So floating particles which will scatters the light. So now we are going to do the experiment to study the scattering of light for both why the sky appears to be blue. Why the sky appears blue and as well as how the sun appears to be red. Understanding during sunrise and sunset. Is it okay, guys? Sunset and sunrise.
In experiment, we are going to study,
Yeah,
sir.
experiment we are going to do this. So sunrise and sunset also we can call it as what? Dawn and dusk. What we should call? Dawn and dusk. Please all of you remember that. Sunrise and sunset. Sunrise is called as dawn and sunset is called as dusk. Please all of you remember that. So now, if you want to understand this experiment to study the scattering of light. So we want to be some kind of setup. So we will discuss experiment to understand how the scattering of light leads to the blue color of sky. First one, blue color of the sky, and as well as second one, and the red appearance of the sun during sunrise and sunset. Both we will study now. So in this experiment, we will prepare a colloidal solution. First we will take the true solution. Later we will take the colloidal solution, which containing a tiny particles of sulfur. What is the colloidal particles, Ra? MCQ question. What is the colloidal particles? Sulfur. Understand? So we are taking a colloidal solution which containing the tiny particles of sulfur which is required. These sulfur particles only will scatters the light. All of you should remember. Who will scatters the light, Ra? Sulfur. Understand? So sulfur which is required for scattering the light by the action of understanding. So this sulfur particles will scatters the light by the action of two things. One is with the help of sulfuric acid. What is that? Sulfuric acid plus sodium thiosulfate. What is that, guys? Sodium thiosulfate. Do you understand, Ra? So if we'll mix these two substances, then because of this reaction, it will release the sulfur particles. What is that, guys? It will release what? Sulfur particles. Understand? So these sulfur particles only will start scattering the light. So that is what we are going to study now. Do you understand, Ra? Shall we start? Please respond me.
Yes, sir.
In this experiment, who is scattering the light? Sulfur particles.
Sulfur.
Understand? So how these sulfur particles are coming? They will scatter the light by the action of what? By the action of two substances. What is that? One is sulfuric acid. Another one is what? Sodium sulfate. What is that? Sodium thiosulfate. That is what you have to remember. So now, to understand this, I will show you two images. So please all of you understand first. So first one, if you'll observe, generally I will show you 1 minute. Yeah. So please all of you look into this image. Now you can see first experiment what we will do means we will take without sulfuric acid and sodium thiosulfate. Now this is what the experimental setup for studying the experiment to study the scattering of light. So here you will observe your textbook also the same image is there. Is it yes, guys? Your textbook also same image will be there. We want one source of light and we want two lenses. Which lenses are there? Concave or convex lens? Observe very carefully and tell me. Concave or convex lens? Tell me, Concave or convex lens? Both are. Nobody is saying. It is converging. See, becoming parallel. And here also converging. So it is what? Convex lenses. What is that?
Convex.
Convex lenses, and we want one transparent beaker and a pinholed cardboard piece, and we want one white screen. What is that? One white screen. So this is what the experimental setup we want. Now, first we won't add sulfuric acid and sodium thiosulfate. First we will take a clear water. How much, Ra? What we will do? A clear water we will take. Understand, guys? Please respond me. So if you'll observe here, understand. So I am taking a source of light, a very strong source of white light. Understand? We will consider this source of light to be the sun. This is what the sun. Understand? So sun, which is producing a strong white light. So they are all going in the different directions. So that is why I want to make it into parallel. You may be notice it. Convex lens. Convex lens. What is the property? The light which is coming from the focus. What will happen after striking the lens? It will become what? You have to speak. It will become what? It will become parallel. Is it yes or no? The parallel light will become converging into the focus. The same way which is coming to the focus will become parallel to the principal axis. Is it yes, guys? Respond me.
Yes, sir.
Yes. The same way convex lens. If the light is coming parallel, what will happen? You respond me. Parallel to the, what will happen? It will be
Convergent focus.
focus.
Going to the focus.
Lens 1, this is happening, and lens 2, this is happening. Is it yes or no, guys? Respond me, Bhumiga, Varshini, Yalini. Is it correct or not? So the same thing.
Yes, sir.
We are using convex.
Yes, sir.
So to focus, to make the light into parallel beam of light, we are using L1 here. So this L1, the light which is coming from the sun, which will be make it into parallel and will allow to pass through a clear solution. Understand? This is what you can take, a clear water you can take. Now you can observe very carefully here. First, if I will pass the light through this, then there is no scattering of light. Are you observing, guys? Just light is going parallelly, but here the speed of the light is decreases. Is it yes or no, guys? Speed of the light is decreases. Is it yes or no? Tell me. Yes. Speed of the light is decreases. Anybody? Why the speed of the light is decreases? Because it is
Rarer to denser.
entering
Sir, rarer to denser, sir.
Very good. It is entering from rarer to denser. Now, are you seeing any scattering of light here? Just the light is traveling.
Parallel.
Here you can see most of the light is striking this cardboard. So we are arranging in a certain setup that only few light rays need to passes through the passes and need to be touch this lens too. So now if you observe here, so some light rays are coming through this pinhole of the cardboard and they are falling on lens too. So now lens here, convex lens too. What is happening? A parallel beam of light is coming. So parallel beam of light is coming. What it will do? It will focus on a particular point. Is it yes or no, guys? Yes or no? It will converges at the focus. So now here same thing is happening. So whatever the light is coming, a parallel beam of light falls on this lens too, and you can see it is just forming the image of the same white light. Here yellow color is there, but it is what is the color of this one actually? It is the white light. Understanding? So white light is forming because of why, guys? Can you able to say why here? Why white light is forming? No scattering of light takes place. Understand, guys? No scattering of light takes place. Why? Anybody can say? Because it is falling on which medium, Ra? It is traveling on what? White light. It is traveling on true solution or clear solution. So clear solution, no scattering of light will take place. Is it yes or no, guys? Respond me. So it is the clear solution or else clear water. So no suspended particles are present between to scatter the beam of light. That is why the white light, the sun color, the sunlight is white in color. The same white color patch is forming on the water, a screen. Understand, guys? Yes or no? Respond me. Nobody is responding. Yes, that is what will happen. Now, we want to study the experiment to study the scattering of light. That is why you can see. If you want to form the image on the screen R or else image of the screen M and N, understand? So we will add some kind of chemicals to this water, clear water. That chemicals only. What we should call, guys? One is sulfuric acid, and the second one is what? Sodium thiosulfate. What is that? Sodium thiosulfate. So these both chemicals will react together and they will produce a what particles, guys? What particles? Sulfur particles. So these sulfur particles, now this is the clear water becomes water. Before it is clear water. Now what it will become? It will become what?
Colloid solution.
Colloidal solution. Understand? So it will become colloidal solution. So that is what it will happen. Now we will study if it will turns into the colloidal solution, then how the scattering of light will take place and what is the phenomena behind, we will discuss. So observe very carefully. So these two diagrams you have to remember. So this is the diagram. Please all of you take the screenshot. This is the most important diagram.